Hello and welcome to Tyler Programming, and today we're going to be going over the queue data structure. Now, I've talked about the stack before, and with the stack, we've gone over the LIFO principle, which means last in, first out. So the last element inserted will be the first one out. Okay, now with the queue, we're going to be going over the FIFO principle, which means first in, first out. So the first element inserted will also be the first one out. So to understand this, let's go over the queue data structure, some common methods, and then implement the code. Let's get started. Here's an image from Roller Coaster Tycoon, which is an awesome game, by the way, and it depicts a queue for an amusement park ride. We have the beginning or front of the queue, and then the back of the queue. As I said, this uses the FIFO principle, first in, first out, which means the person in front will always get on the ride first. The person that is currently last in line will be the last one to get in, assuming nobody else joins. Some other real-life examples include reservations, call waiting, or a waitlist. In the computer science world, something like a networked printer or a web server responding to requests would be other examples. Now that we went over a little bit how a queue works, and you have basic understanding, let's go over the common methods and how we're going to implement the code for them. First off, here are the methods that we will be using. OnQueue, which takes in a single parameter, which is an element or what the value that we're going to add to the queue is. We have Dequeue, which is we're going to remove and return the first element in the queue or return null if empty. So we're going to remove whatever is in the front of the queue, but also return it to us just so we can do like a printout and see what it was. We have the first method, which just returns the first element without removing it, kind of like peeking at the front of the queue. We have size, which just returns the number of elements in the queue. And then finally is empty, which will return true if the queue is empty or false if it's not. So right before we get ready to code it, we have to think of how we are going to implement this. There are a couple ways, and you can use arrays or linked lists to store the elements. In this video, we're going to use an array implementation, but you can certainly, once you finish this, try to create your own linked list implementation as well. Let's think about this. Here is an example of an array with a length of 12, and it has a size of 6, meaning that's how many elements are in this array. Now, I know this array is not necessarily proportioned correctly, but I can't draw, and this is the best I can do. So something we know about arrays is that they cannot change in size. So because this has a length of 12, that's it. We can't do anything about that. So since it's a fixed size, when we do the insert operation or onQueue, this is going to be a pretty simple operation and quick because it's a fixed size. Inserting, not an issue. But what about removing an element? Well, let's say the front of the queue is at index 0, and that's how we start. The front of the queue will be at index 0, the back of the queue will be n-1. If we were to remove the element at index 0, so let's go ahead and remove 3. So we just performed a dequeue operation. So remove the element at index 0. Well, we can move all the rest of the elements over 1 or shift them over 1. So this would be 8, 4, 7, 5, and then this would be 6. Okay? So we shifted all these over 1, and the front of the queue stayed at index 0. Now, that works, but it's somewhat costly because when we code this, you're going to have to use a for loop. And a for loop typically has a big O log of n operation. So maybe we can do a little bit better. All right, so let's start back at where we were. What we can do is replace the dequeued or removed element with null, and then keep the front reference with the new front element. So we'll just move it over 1. So what does that mean by that? Well, let's do a quick operation. Let's dequeue again. So that means we remove 3. We said we're going to replace it with null. Then we're going to keep track of the new front reference. So the front reference would now be at index 1, where the value of 8 is. Okay, and that's how a queue works. However, if we were to keep doing it in this fashion, eventually we keep dequeuing. Well, eventually f would be all the way down here at index 11, and then you can't go right anymore because the array is a fixed size. Well, the fix for that is letting the array wrap around, or like a circular array. But in order to do this, though, we'll have to do a little bit of math with something called the modulo operator. So let me restart. So let's restart again. Here's the math that's going to come in. You need to understand, because when we code this, we're going to be doing the exact same thing. It's going to make this a lot easier. Let me just write it out first. We're going to say f for front is now equal to f plus 1 modulo the length of the array. In this case, it's 12. Now, what's modulo operator? Let's do a couple quick examples. If I were to say 3 mod 5, 5 does not go into 3. It goes into 3 0 times, and then the remainder is 3. But if I were to say 8 mod 5, 5 goes into 8 one time with a remainder of 3. And if I said 5 mod 5, 5 goes into 5 once with a remainder of 0. Okay, now with that knowledge, we can start substituting some variables. So f is going to be equal to f, which is at index 0. So 0 plus 1 is 1 mod 12. Now f equals 12 goes into 1 0 times and has a remainder of 1. So what we're saying here is when we dequeue, the new front reference is going to be at index 1. So we dequeued, 3 is equal to null, and f is now pointing to index 1. And so you might be wondering, well, when we get to 11, we'll say 11 plus 1 is 12 modulo 12. As stated, 12 goes into 12 once with the remainder of 0. So f would then come all the way back around to the index at 0. We're going to code something very similar for onqueue whenever we insert something, okay? Because we have to, when we insert something, we have to tell it where to insert, right? So for onqueue, let's say we have the same setup right here. Let's onqueue 9, okay? Now, what's the formula for this? Well, it's pretty similar. We're going to create a new variable. Let's just say int I is equal to f plus size of the array mod length. So we're replacing the constant of 1 with the size. So I is equal to f, which is currently at 1, plus the size, which is 5. So f plus 1, because remember the size is how many elements are currently in there. It was 6 until we dequeued 1, and now there's only 5. So 1 plus 5 is 6. Mod the length of the array, which is 12, equals, and 12 goes into 6 0 times with a remainder of 6. So this means I equals 6. So in this data, in the array at index 6, we are going to insert 9. Okay? And that's how dequeue and onqueue are going to be working. Now, we finally understand this. A little bit of math involved. I apologize, but it's just the way it is. Let's code it. Okay, let's get started. Let's create the queue class. So queue array. We need to do a couple things. We need to declare the actual array. I'm going to use integer because I want to set something to null, and you can't set a primitive int to null because that's how I explained it. So that's how I'm going to show you. You might want to. I would show this with generics. Maybe in another video I'll show how to do this with generics. But for now, we're just going to use the integer wrapper class. Just call this data. Then we need to declare the front element. Let's just say it's front, and it's going to start at index 0, so front is equal to 0. Private integer. We also need to declare the size of the array. It starts out at 0 because there's nothing there yet. We don't have any elements. Let's go ahead and queue array. We're going to give it an initial capacity. So we'll say data equals new integer capacity. Okay, so when we declare or we create an object, we'll give it an initial capacity. So let's start out with some of the easy ones. Let's do the size method. Public integer size. We're just going to say return size. Pretty simple. The next one is the isEmpty method. I always like to do the low-hanging fruit. So it looks like you got something done, and they're supposed to be the easiest ones. So we want to return a Boolean here. So all you have to do is say return size equals 0. Okay, and if size is equal to 0, it will return true. Otherwise, return false. Okay, so the next one we want to do is, let's go ahead and do the onQueue method. So that's when we add something. All right, so with onQueue, we're just going to add the element. Don't need to return anything. So public void onQueue. We need an element for the parameter, or some sort of integer. So if the amount of data we have, so the size, so if the amount of elements is equal to data.length, the length of the array, meaning that the array is filled up. What we could do is you could do a system printout, or you can maybe throw an error. What I'm going to do is just do a system printout. I'm not going to worry about the error right now, just so you can see. So if we do a printout, queue is full. All right, and then what we'll have to do is, well, what is going on? We'll have to do a return, okay, so that we can exit out of it. Then we're going to say int. We need a variable, so next available index. Because when we add it, we want to see where the next available index is. Okay, so just like we did whenever I explained the formula, it's front plus the front element plus the size. So front is a reference to the index. So the index plus the amount of elements in the array modulo the length of the array. Okay, so then what we're going to do is we're going to insert, we're going to say the index, whatever this index is, we're going to insert the new element into that index of the array. All right, and then last thing we need to do is to increase the size of the array, or the number of elements. All right, now we can go ahead and do the next one, which is going to be the first integer first, and this is just going to return the element that's in the front of the queue. So we say if is empty, then we just return null. And if you're just using regular int primitive, you can just say return -1. So anything in your array that's -1 means it's null as well, okay? Just for learning purposes. So otherwise, if it's not empty, we're going to say return data front, which means in the array, we're going to return the value that's in the front of the queue. Okay, because remember, front is a reference to the index. And the last method we need is the dequeue method. So we're going to say public, integer dequeue. We do not need any parameters. So if is empty, so that means if it's an empty array, we can't remove anything. So we're just going to say return null. And then we need our formula. So first we're going to get where the current what the current front element is. Integer. Where the current front element is equals data front. And now we can say data front is equal to null. And let's do our formula. So the front is now equal to front plus 1 modulo data.length. Size, decrease the size or the number of elements, and then we want to return the current front element. So the current front element is what's there right now, and because what the dequeue method does is it removes the front element, but we want to return to the user what it was. Okay, you don't have to do this. You can make this a void method and then just not, but just for more testing purposes, maybe I kind of want to do this. And the last thing we need is a print method, just so we can see where we're at. So print q. Now we need a for loop, int I equals 0, I is less than data.length, I plus plus. Then we'll do a system.out.print vertical bar. I like vertical bars for whatever reason. I don't even know why. Okay, and then the last one, we're just going to do a system.out.println. Okay, now we finished coding everything. I'll go back through this again if you don't quite understand or redo this section. But now let's do a little bit of testing. Okay. Okay, so here we are to test it in my main method. I instantiated a new object of QArray that we just created, and I set it to a capacity of 5. First thing I'm going to do is just do a system printout of the first element in the queue. So this should return null because that's what we're supposed to return if it's empty. Okay, awesome. Now let's do, whoops, like dyslexic or something. Let's do QA.onQueue, let's say 3, QA.onQueue 5, QA.onQueue 9. Okay, and then we can do QA.print queue. So if we test this, it should be 3, 5, and 9, and then null, null. Okay, because this is, I know I said if it was a numeric primitive class array, they would be filled with zeros, but because this is a wrapper class, it's a reference type, and they're going to be instantiated with nulls instead. I said that in my array video. Okay, so we have 3, 5, and 9. Now let's go ahead and let's just unqueue 2 more. Let's do 1. I guess we can just copy this here and do 2 as well. So this should basically print out just like that, 3, 5, 9, 1, and 2 in that order. Now if we dequeue, this is going to, it should set 3 to null. Oh, whoops, I didn't do another printout. Got scared for a second that my code didn't work. All right, so we're going to dequeue, then do another printout. So 3 should be null. That is correct. So if we do system.out.println, get the first element, so we're going to print out what the value of the front element is, it should be 5, and it is. Okay, so now if we wanted to, so the front element is 5. Now what happens whenever we want to enqueue or onqueue another element? Well, it should go in index 0 where null is. So if we say QA.onQueue, let's say 10, and then do another print queue, 10 should be in index 0, but if we see where the first element it should still be 5. And it is. Okay, so this is where the wraparound happened. So we got to the end, but we still need to onqueue or add another value to another element to this array. We just went to the next available index, which happened to be 0. Now let's try to onqueue another element, and we shouldn't be able to because it should say, oh, it shouldn't allow it because it's already filled up. Queue is full. Okay, so then let's just do another print queue to make sure that it actually wasn't added. Yep, nope, 15 is nowhere to be seen, and that's a good thing. All right, guys, well, we coded our queue using an array. If you have any questions or comments, please leave them down below in the comment section. I will get back to you, and I'll leave a link from my GitHub where I will put this in my GitHub repo. Okay? Happy coding, and I'll talk to you guys later.